Welcome to the next section of 2 watt meter reading. The other time we tried to determine the magnitude of the 2 watt meters that are placed on line A and C using that is using a star 3-phase 3-wire star balanced star connected system to determine the magnitude. But this time around we want to determine the power factor. We want to know how to obtain the power factor using of a 2 watt meter. That is to obtain the power factor in the 2 watt meter that are connected to line A and C. And to do that, I'm going to use a phasor diagram that is ABC sequence, that is positive phase sequence, with a lagging current that has phase angle phi being assumed. Now, this is the phasor diagram that I talk about, that is VAN, VBN, VCN. The direction of rotation here indicates that it is positive phase sequence, where IA lags BAN by angle phi. Right. Now, when we look at the phasor diagram, WA, the wattmeter reading A, which is made up of the voltage and the current, the product of the voltage VAB and the current IA, with the power factor VAB and IA. So we need to know what is the angle between VAB and IA. This is VAB and this is IA. This is IA. So between the line voltage and the phase voltage, we have 30 degrees. 30 degrees difference between line and phase. So now between VAB and IA, which is VAB and IA, it is 30 degrees plus phi. So that leaves us with VAB IA cos 30 degrees plus phi. That is the wattmeter reading in A. So if we want to look at the wattmeter reading now in C, the wattmeter reading in C equally will be what? The voltage across C and the current, which is VCB times IC. VCB IC cos at angle VCB IC, which is equal to what? VCB IC cos, we need to know the angle between VCB and IC. Where is VCB? This is VBC, so if we project it backward, we have VCB. Right. Then we want to know the angle between VCB and IC. So VCB is this. Where is IC? Our IC is here. This is our IC. Right. So if this is our IC, we need to know the angle between this IC and VCB. So if you look at it very well, between here, IA and IC, between line current and the line current is 120 degrees apart. 120 degrees apart. That is the angle between here and here. But between here, between IA and IC is what? Is 120 degrees. Then between here, IA, and here is phi. Between here and here is 90 degrees. So let's 90 degrees plus phi, we take it away from 120 degrees. That is minus 90 degrees minus 90 degrees, because we have 90 degrees plus phi. We take it away from 120 degrees to give us this, which will give us 30 degrees minus phi. So that means we have 30 degrees minus phi as the angle between VCB and VA and the IC. And that tells us that is the, then the next thing we want to do is we now want to determine, that is, we determine it, when we determine it mathematically, when we work it out mathematically, which I will explain to you further how it is done if time permits. When you use this, you find when you do it out mathematically, you are going to come to the conclusion that is when you expand this, and you find the sum and the you find the product, the ratio of the difference between the readings and the sum. The ratio between the difference in this reading, that's WA minus WC, the ratio between the difference and the sum, you come to this particular equation. Tan phi is equal to root 3 into WC minus you come to this tan phi, which is equal to root 3 into WC minus WA over WA plus WC. So this is what you finally get out from when you mathematically express this. You come up with this particular equation. This equation is what you will use to be able to obtain the power factor reading in this wattmeter. And for this also we have different, what will help you to determine this will be informed by two things. It will be informed by on which lines did you put the wattmeters. If the wattmeters are placed on A and B, the equation will be different. If it is put on C and B, it will be different. So that means what will help you to determine where what formula you use to obtain the power factor will be the lines on which the wattmeters are placed. Number one. Then number two, the direction, the sequence of rotation, whether it is positive sequence or it is a negative sequence. Right. If it is positive, you are going to have a totally different formula as opposed to when it is negative. So now let me quickly write out what you are going to have. For example, when you have it on A and C, this is what you get. If you have it on B and C, let us assume you have this wattmeter is on B and C. There's nothing on A. You have it on B and C. This is what you are going to have as your equation. Tan phi is equal to root 3 into WB minus WC over WB plus WC. If you have it on only on C and A, I've already determined that. If you have it on A and B, let's say you have it on A and B, there's none on B. You are going to have tan phi is equal to root 3 into WA minus WB over WA plus WB. Right. That is, it is assumed now that you have it on C and A, but it is positive phase rotation. You have it on B and C, it is positive. You have it on A and B, it is positive. If you have it on C and B, right, but it is negative. If it is negative, because all this indicates we are saying these are positive. If it is negative, that means you just change only the top. If it is negative sequence, it will be WC minus WB. If it is negative sequence, it will be WA minus WC. That is just the difference. If it's a negative sequence, it will be WB minus WA. Right? So, the denominator doesn't change. The sum will remain. So it will be so. For example, let's take this one. If it is on C and A, it will be tan phi is equal to root 3 into WA minus WC. This denominator stays the same, WA plus WC. Right. So those are the formula that we are going to use to obtain the power factor. If furthermore you want me to quickly prove to you, I will take time to prove it to you. But also, if you struggle to know how to memorize it to be able to make it easy in case of solving problems, I can also help you. In the meantime, I would like you to go through your books and try to go through it to understand it. Where you don't understand, you let me know. Thank you.